Hello everyone, welcome back to STATA Part 3. In this we will mainly focus on the errors and the regression model 2 with differences. So I'll just write the regress formula with d dot with every variable and run this. Okay, now let's see the results. So p-value it's less than 0.05 means the overall model is significant. We will copy this and paste this in our Word file. Regression model 2. This we'll do just a little bit of formatting so that the readability it's good of or as per the format of the report, right? Let's reduce the font size. Okay, now we can highlight the key statistics like p-value, sum of square error, mean square error. On the previous one, I've mistakenly highlighted both the mean square error, so just remove this and highlight the sum of square errors. Okay. Now we'll compare the errors of both. This is 175,510 and 43877. And the new one we got 18206 and 4551. Means the errors are reduced in the second regression model, which we have created using the differences. So this model is quite effective as compared to the previous one, right? So I'll just highlight the coefficients, all the coefficients. Okay, now the p-value of all the variables, right? So first variable is significant, second is also significant, third is insignificant, that is price in dollars, and competitor price is also insignificant. So we can write in our analysis that price for this model, price is not an important or key variable for on which we will our which affects our dependent variable. It might be because of the location where the hotel is located, or it might be due to the season or time of the year where tourists are irrespectively decide on a hotel based on the availability and not on the price. Okay, I'll just copy this regression model, copy here, and then replace the coefficients, the results of this one. See, the constant is also reduced very much to negative 3.18. It's 1.37. Almost similar results. So the coefficient relationship is like more effective in this model. So this model is ready. Now we'll just write the analysis as we have written in the previous one. And further to this, this is the final regression equation. However, we can remove price in dollars and competitive price from this model while analyzing it. Like initially, we'll write the whole model, and then with the analysis, we can shrink down the model irrespective because price and competitive price are insignificant for this model as well and for the previous model as well. So we can either write in it or we can remove it. It does not matter. And right there we have run regression model in two variants, one with the raw data and one with the differencing. However, in both model price and competitor price are insignificant. Therefore, we can drop these variables from our final model, final analysis. So our actual regression model will be uh, derived from the existing equation, where we will just remove price and competitiveness. So actually for this data, to predict the dependent variable, only two variables are effective and significant. And the last one is error. And now we'll run all the errors. I will predict reset 1 for this regression model. Residuals will be predicted as reset 1. Underscore 1. Okay, now we'll run the dark para test, JB reset. So we've run JB reset, VIF test of for multicollinearity. This has also reduced. In the previous one, it was 54, and now it is around 1. That is, the error of multicollinearity has been removed from the data. Then E state head test, heteroscedasticity. Earlier as well, there was no error of heteroscedasticity, and in this model, also there's no error of heteroscedasticity. IM test is also similar to head test, and the results of this has also improved. He said D Watson's, and D Watson is also around 1.8, 1.89, meaning it is around 2. 0 to 1.5 is positive autocorrelation, and 2.5 up till 4 is the negative autocorrelation. Earlier there was positive correlation between the variables, and now it has reduced to 2, that is around mean, and there is no autocorrelation error in this data. Okay, so if we compare both the models, the second one is more significant. It has reduced low errors, and we can use this model to predict our dependent variable. Okay, now in the question, we have run multiple regressions and identified that the second one is the most accurate regression equation. Interpretation of all the coefficients, like a constant is negative and all the independent variable has positive relationship with the dependent variable. We have prepared line chart and histogram and scatter plot in the part 1 of this video. We have performed unit 2 test in the part 2 of this video. We have analyzed correlation matrix, and in this video we have calculated all the errors: heteroscedasticity, multicollinearity, and Durbin-Watson. Okay, basically we have completed all the requirements. If you are preparing for an examination, you must understand that all the steps must be carried out sequentially. Like first make the graphs, then run the correlation matrix, then check the stationarity of the test. Graphs will also tell you whether your data is stationary or non-stationary. Then you can perform D-Fuller test to check the stationarity. Then you can run the regression equation, and then all the errors, and if required, then transform the data and run the regression equation. I will just highlight all the tests. This is dark para test. Chi-square is greater than 0.05, so the result is significant, means the data is normally distributed, and it is not negatively or positively skewed at any point in time. So there are two differences. First is chi-square must be greater than 0.05, then the results are significant. And if p-value must be greater than 0.05, then your results will be significant. Otherwise, if p-value is greater than 0.05, the results are insignificant, and we have to either transform the data or change the variable. And for chi-square, if p-value is less than 0.05 means the error is there, and we do not reject null hypothesis. Okay, for VIF, the error is, of multicollinearity is removed when the data was treated with differencing. Hence, the model has no error of or multicollinearity. A test, chi-square is the greater than 0.05 means there's no error of heteroscedasticity. D Watson is 1.89. Uh, the data when treated with differencing, yeah, with the data when transformed, it neutralized the error of Durbin-Watson error. Here I'm checking that if D Fuller, if competitive price or price in dollars can be transformed in another way to make the variable significant. You can do this on trial and error basis when you are doing actual research. However, while during a certain activity exercise, you may skip multiple checking of the transactions commands, right? Okay, so this is the last regression equation. This is Praise Corp regression equation. Whatever we have done previously to transform the data or without transforming, the Praise and Corp, what they do is they run multiple iterations on the data with transformation and without transformation, and whatever the best equation, best model they can derive, it is it can be it is available, right? So whenever you are doing your research, you can first do the trial and error thing, and then lastly you can check this like Praise Corp equation, Praise, and then I'll add this here, Praise, regress, rooms, and comma, Corp, right? This is equation. Not this one. Okay. I'll do it without regress, right? Trace all the dependent and dependent variable and call. Okay. So this is the best model for this data. And if we compare, then this model is almost similar to the one with the differencing, which we have created, the regression in model number 2. So to check your data, if you have performed multiple transformation on the data and which model is significant, you can check with Praise and Corp model. This was the last thing in the regression equation. Hope this video will be helpful for you in your future researches, and please do give your feedback on this video so that I can do more improvement and add more explanation and features in it. Present Corp also calculates Durbin-Watson statistics, so it's easier to run this one equation instead of running multiple equations. So this is for your learning and practice. Um, and best of luck for your future. Thank you. Bye bye. And just do not forget to create, begin your log and close your log. Bye bye.